Okay, so in this video, I'm gonna talk about the double integral over rectangular region. So you have the surface z equal to fxy. I told you before that this guy is called surface. Okay, so this one is called surface. And the problem that we are dealing with will be, how would we find the volume of the solid? So you see here that you have a solid. It looks like a bar. Okay, so if you like to find the volume of the solid that bounded above by the surface, and it's going to be over the xy plane. So you have the xy plane, okay, and you have this one. If you just think about this one as a floor. Okay, so if you have the floor down there and you have the surface up there, normally the question turned out to be, how could we find the volume of this solid? Okay, if you recall calculus 1 given in the way that you are having the graph y equal to fx, and you are computing the area in the interval a to b. Okay, so you have the integral from a to b of fx dx. Okay, so you have the integral a to b of integral fx dx, and this one will be the thing that you have learned that is gonna represent the area under the curve y equal to fx over the interval AB. So this one, the area will be just integrate from A to B of fx dx. Okay, so that will be the area that under the curve. However, if you have a surface z equal to fxy over the rectangle D here, okay, so it's going to be over rectangle D here. How could we find the volume of the solid that bounded above by the surface and bound below over the rectangle? So you see, or you can imagine that this one is a rectangle in two-dimensional. Okay, so if you flip this one and you draw this guy in 2D, so it's gonna be what? It's gonna be like this. And okay, so you have xy and you're gonna have a b c d. Okay, and you see that this one will be just the green one, and this one will be just the yellow one. So I have the yellow one and the green one respectively, and the rectangle D turned out to be just this small rectangle D like this. Okay, so it's going to be A, B, C, D, okay, and this one will be just X, Y, okay, for the rectangle D, okay, and you like to find the volume of the solid uh, above this region D. So in this case, you're gonna subdivide the rectangle D into smaller pieces, and you see that you're gonna compute the rectangular bar. Okay, so it's going to be a rectangular bar like this. When you are having rectangular bar, you'll be able to compute the volume easily by just you have the width times the length times the height, and you'll be able to obtain the volume of the bar. And you see that you may sum this bar up, and okay, so it's going to be the volume of the bar turned out to be the area of area of Rij, so which is this small rectangle here, and it's going to be multiplied by the height. The height will be the height of your surface here. So it's going to be f x I j y I j delta x I delta y j, okay, because you see that this one will be small delta x I and here it's going to be delta y like this. And you see that if you sum the whole thing up, you're going to get kind of the volume of the solid that you have lying under this surface. Okay, so how good this one is working? This one, you see that if you have this subdivision and you see that you're gonna miss something, okay, you're gonna get some error. However, if you have this guy turn out to be smaller, you're gonna be able to get rid of the error and it's gonna turn out to be the exact value that you have. So in this case, we're gonna just take the number of the pieces turn out to be infinity. So if you have this guy turn out to be infinity, which is this guy turn out to be very small rectangle, okay, so it's gonna be kind of phi like this one. You see that you would get the volume of the solid, and this limit turned out to be the volume of the solid under the surface that equal to fxy over the rectangle D. Okay, so this limit of fmn, this one has a special name that you don't need to worry. So this guy sometimes is called the Riemann sum. Okay, so this guy is called the Riemann sum of f over d. However, the thing that concerns you turned out to be, how could we compute this one without using a complicated sum like this one? It's going to be just, you see that it's like to find the area. When you like to find the area, you just integrate from A to B. So for calculus 2, it's going to be integrate over D. Okay, so it's going to be integrate. It's not going to be an integrate from A to B. So it's going to be integrate over D. So this one will be the thing that you need to concern. So it's going to be integrate over D. However, to indicate that you are doing calculus 2, so it's going to be double integral. So this one is double integral. Why do we need double integral? Because we like to distinguish between calculus 1 and calculus 2. Calculus 1 is going to be just integrate from A to B. Calculus 2 will be integrate over two-dimensional. So when you like to integrate over two-dimensional, so you like to integrate over the rectangle D like this. So you integrate over rectangle D. So here you integrate over interval AB. So you have only one integral. Here you have two integral. And it's going to be with respect to x and with respect to y. So it's going to be taking care of integral on dx and integral on dy separately. Okay, so this one, when you like to integrate over d, you're gonna see that it's gonna turn out to be, let me copy this picture to the other page. So you see this picture here that is gonna take care A to B and C to D. Okay, so it's gonna be taking care A to B and C to D. And you see that if you have integral from A to B, so you are on the x variable. So this one will be x. So you see that it's going to be integral from A to B and dx, okay? And you're going to have integral from C to D and dy. So you see that it's going to be taking care the variable x and taking care the variable y separately, kind of. So it's going to be, you see that it's going to be integral over rectangle D here and D consists of from A to B and from C to D. So in this case, you're gonna have integral from A to B of fxy dx inside, and you have integral from C to D of uh, fxy dy also inside. However, the thing that you may have to see turned out to be, you see that it look like putting parentheses, the color is corresponding. If you like to have dy inside, if you like to have dy inside, the thing that you're gonna do will be you're gonna have integral from C to D inside, and you're gonna have integral from A to B outside. Okay, so it's gonna look like that. Okay, so you see that the color is correspond. So you see green guy, yellow guy, and green guy, yellow guy. Okay, so the color kind of correspond, and this one will be just the volume. However, in the case that fxy is equal to 1, okay, it's turned out that when you have the fxy equal to 1, it means the height is equal to 1. So you have integrate 1 dA, and this guy turned out to be giving you the area D. Okay, so only the area D here. So if you have the height here, which is kind of the constant one, okay, the volume turn out to give you the area of the region D. Okay, so this is going to be that. I know that you may think that, hey, why don't you just have the area D by just multiply B minus A and D minus C? Yeah, you can. However, I talk about this one for any general D, okay? D not necessary to be the rectangle all the time. We're gonna see D to be other region in the next clip, okay? Let's try to compute this one. We like to evaluate the double integral. So this guy is called the double integral, okay? And the function is x plus 2y and dA. So it's going to be the difference on the area. So dA can be two things. dA can be dx dy, and dA can be dy dx. I show you both for this example. So you see that this guy will be integral, and you have x plus 2y, and I would let dx dy first. I have dx dy, and you see that the green one represent x, and this one is your x. Okay, so this one is your x, and the second one turned out to be y, so you have y, which is the yellow one. Okay, so this double integral will be, you have the green one from -1 to 1, so you just put -1 to 1, and this one turned out to be the green integral. And the second one turned out to be integrate from 1 to 2. So this one will be the yellow one. So it's going to be 1 to 2. And this one, like this. Okay, so this one will be, you use dx dy. However, if you like to use dy dx, it will be giving you the same value. So it's going to be x plus 2y. But the difference turn out to be you will have dy inside and dx outside. So you have the yellow guy inside and you have the green guy outside. So in this case, it's gonna be negative 1 to 2 inside and -1 to 1 outside. So this one is the green one, and this one is the yellow one. Okay, so this one is gonna be the yellow one and the green one like this. And how could we compute for value? The way to compute for value is look like the thing that we usually do for parentheses. We're gonna compute the inside first. Okay, so we're gonna compute the inside first. It look like putting parentheses like this, and you're gonna compute or evaluate the inside. And how could we evaluate this guy? Is going to be like in the previous clip that I asked you to integrate, and you see that you are integrating with respect to x. So you see 2y here turn out to be constant. Okay, so in this case, you just integrate each term down. So you integrate x dx, so you get x squared over 2. And you integrate 2y, so it's going to be 2y multiplied with x. Okay, and this one will be just taking care of the integral. So you have constant, so it's going to be 2y, and you integrate constant. It's going to be 2y times x dx. And this one will be from x equal to -1 to x equal to 1. And this would allow you to have plug in x squared. So it's going to be 1 squared over 2 plus 2y times 1 subtract by -1 squared over 2. Okay, so it's going to be subtract by -1 squared over 2. Okay, plus what? 2y times -1. Okay, so it's going to be 2y times -1 like this. Okay, and you see that it's gonna be, okay, 1 over 2 minus 1 over 2, so they cancel. So this guy will be 2y plus 2y. Okay, so it's gonna be 4y. So it's gonna be 4y for me. Okay, and this guy and this guy, you get rid of them. Okay, so this is what you have. And then you see that you're gonna have the outside, so you're gonna copy down the outside. So it's gonna be 1 to 2, and for dy you're gonna copy dy down. And you see that it's turned out to be calculus 1. Okay, so it's going to be, this guy turned out to be equal to integrate, and the inside turned out to be 4y. Okay, so the 4y, let me put parentheses for you here. So it's going to be 4y. Okay, so this is the thing that you have inside parentheses. And then what? And then you're gonna integrate this 4y. Integrate 4y is gonna be 4y squared over 2 from 1 to 2. Okay, no need to worry about any other variable right now. And this guy will be 2 squared minus 1 squared. So it's gonna give you total equal to 6. Okay, so this one is the first double integral. Okay, so you get this guy equal to 6. The second one, okay, that I will move this one a little bit. So for this one, if I ask you to compute for value, it will be the same thing. You're gonna compute inside first. Okay, so let me begin by computing the inside. So you're gonna integrate from 1 to 2 of x plus 2y dy first. Now you are integrating with respect to y. You end up with constant x. And this guy turned out to be xy plus integrate 2y will be y squared. Okay, so it's going to be xy plus y squared. And you're going to have y equal to, you're going to have y equal to 1, y equal to 2. Okay, so you get 2y plus 2y squared, not 2y squared, 2 times 2 squared, minus y, okay, it's going to be x equal to 1, so it's going to be y plus 1 square. So you get y minus, not minus, plus 3, okay, so you're gonna get y plus 3. Sorry, I should plug, this can happen. I'm gonna have to plug y equal to not x. I plug into x, sorry. So this one is gonna be x times 2 plus 2 square minus x times 1 plus 1 square. And this guy will be x plus 3 totally. Okay, so you have x plus 3 for inside parentheses. And then you're gonna move down the outside. So it's gonna be integrate -1 to 1. And you have dx turn out to be dx here. Okay, so you see this is the thing that sit inside parentheses before. So it's gonna be, you're gonna copy the one that you have for outside. Okay, and this one is you are copying the yellow guy down. I forgot to mention that. Okay, and this one will be the final thing that you need to integrate. So you're gonna integrate x plus 3 dx from -1 to 1. So it's gonna be x squared over 2 plus 3x from -1 to 1. And this allow me to get 1 squared over 2 plus 3 times 1 minus -1 squared over 2 plus 3 times -1. And this would be just 3 plus 3 equal to 6. Okay, so you have this question, and you see that you can do dx dy or you can do dy dx. If you calculate them correctly, they should be the same. Okay, so this guy and this guy are actually the same. You can use the red one or you can use the blue one. It doesn't matter in this case. Okay, so other question, I'm gonna just use dx dy or I just use dy dx. I don't have to do both, okay, because any of them will give me the same number at the end. Okay. For the next one, you have integral, double integral of xy squared plus x squared y dA, where d equal to 1, 2, and times -1, 0. So this one will be your x and y, and you can convert this guy. You have xy squared plus x squared y. I will use the x dy, okay? So it's gonna be 1 to 2 and -1 to 0. So for this one, you see I use the pink one outside and I use the green one inside. Okay, and then you gonna integrate. Okay, so you gonna integrate this one. So you see that if you gonna integrate this guy, you gonna integrate the inside first. So you gonna integrate this one, okay? And you are integrating with respect to x, okay? So you are integrating with respect to x. So it's turned out to be, let's do them together. So you get what? You get for this one, so you integrate with respect to x, so you have constant y, constant, and you have y constant. So in this case, you get y squared, x squared over 2 plus y times x cubed over 3 from x equal to 1 to x equal to 2. Okay, be careful a little bit. Why did I write x equal to 2, x equal to 1? Because I just have to warn myself that I'm gonna put into x, not y, like I did earlier. It's gonna be wrong. Okay, and you have y squared 2 square over 2 plus y 2 cube over 3. This is one term. And you have y square 1 square over 2 plus y 1 to the third over 3. Okay, so this one will be the function in y, and you see that the total that you have will be 3 half y square. Okay, so it's going to be combine y squared together, and you have 7 over 3. Okay, so you get 7 over 3 plus 7 over 3. Okay, and you get how could I have, yeah, it's correct, 7 over 3 and y. Okay, and this one will be the function inside parenthesis. And then you're gonna copy down the outside. So it's gonna be negative 1 to 0 dy. Okay, so this one look like this. So you see I did this guy step by step for you. Okay, and you see that it's turned out to be what? It's turned out to be you need to integrate this guy. So it's gonna be 3 half y cubed over 3 plus 7 over 3 y squared over 2 from negative 1 to 0. And then you see that when you plug in y equal to 0, you would get 0. Okay, so you get putting y equal to 0, subtract by putting y equal to 1. So it's going to be 3 half, and this guy will be negative 1 to the third plus 3 plus 7 over 3, and you have negative 1 square over 2. Okay, and you just calculate for number. Okay, so you just calculate for number. I gonna get negative, so it's gonna be I gonna get 1 half. Okay, and I'm gonna get minus this guy is gonna be 7 over 6. Okay, and this one shall be 6 minus 14, so it's gonna be I should get 6, right? So it's gonna be negative 4 over 6, so it's gonna be negative 2 over 3. Okay, this is the value of double integral. It can be negative. Okay, so this guy can be negative because it's going to be just the value of the double integral, which can take both sides negative or positive. If you interpret the meaning, it means that your surface turned out to be below the xy plane. Okay, so if you interpret the meaning a little bit, it's gonna be below the xy plane. That is gonna give you the value of the function turn out to be negative, and it's turned out to give you negative value for the double integration. Okay. Okay, I hope that I did the number correctly because it's different from the lecture that I have here. The function is different. Okay. Okay, so for the last one, okay, you have the double integral of x e to the y plus y over x dA. Okay, so I will use dy dx for this question for you. So if I write this one as integral e to x e to the y plus y over x dy dx. So you see that you have x between 1 to e and y between 0 to 2. So you're gonna have 0 to 2 inside, okay, and you have 1 to e outside. So for this one, it's gonna be this, and it's gonna be the yellow one, and you have the y, the x, okay, this, okay, and you're gonna compute this one inside first. Okay. Okay, so for this one, I will let you do on your own first, and I give you the solution later during the recitation. Okay, so this one, please do this one on your own to see whether you get the idea how to how to compute the double integral, and I will show you the solution later. Okay, so that's it for this clip. The next one is going to be the double integral over general region.